Good afternoon, students. Welcome back to chemistry class. Today we are going to study about shapes of p, d and f orbitals. Shape of p, d and f orbitals. What do you mean by orbitals? Orbital mean one of the three-dimensional space around the nucleus in which the probability of finding electron is maximum. Okay, the 3D space or 3D region around the nucleus in which the probability of finding electron is maximum, that is called orbital. Okay, the orbital, the 3D space, how will you identify the 3D space? Means here three axes are having here, three axes. What are the three axes? X-axis, Y-axis and Z-axis. Okay, these are about the three axes. Okay, and these three axes are lies perpendicular to each other. Okay, you know, the electrons revolve around the nucleus in a circular path, and within the circular path, the three-dimensional space are having. Okay, that is called the orbitals. Already we studied about that. Here, the three-dimensional space, how it will be arranged. Here, this is the x orbital, this is the y orbital, this is the x-axis, y-axis and z-axis. Okay, with three axes. These three axes are perpendicular to each other. Okay, it will be 90 degree to each other. Okay, these are the three axes, about the three axes. Okay, three-dimensional space. Okay, understood? Then we are going to study about the shape of p orbital. First upon, we have to study about the shape of p orbital. Okay, listen here. This is the set of quantum numbers. Here. The p orbital start from second shell or second orbit. Okay, the second orbit, the L value. What is the L value for the p orbital? L is equal to 1. What is the m value? How will you write the m value? M means magnetic quantum number. How will you write the magnetic quantum number? The magnetic quantum number represents the orientation of orbital. For L value 1 means how to write the orientation? Minus L2 plus L through 0. Okay. So L is equal to 1 means we have to write minus 1, 0, plus 1. Understood? Okay, these are the orientation of M value. So here three orientations having here. The three orientations designated as Px, Py and Pz. These three orientation designated as Px, Py and Pz. Okay, so p orbital, there are three orientations are having. For p orbital, how many orientations are having? Three orientations are having. Okay, how these three orientations are, how to draw these orientations? First upon Px. The Px orbital, this is the Px orbital. You know, the 3D space, this is the 3D space. 3D space means x-axis, y-axis and z-axis. Okay, so Px orbital, it lies along with x-axis. Okay, the Px orbital, it oriented along with x-axis. Then Py orbital, this x-axis, y-axis, z-axis. The Py orbital, how it oriented? The Py orbital, it oriented along with y-axis. Okay. Then Pz orbital, Px, Py and Pz. This Pz orbital, it lies along with z axis. To orientate along with z axis. Okay, these are about the p orbital. Here, what is the shape of p orbital means? The shape of p orbital. The p orbital shape means a dumbbell shape. Dumbbell shape. Okay. What is the shape of p orbital? P orbital shape, dumbbell shape. Okay. And then, what is the shape of? And then the p orbital, how many p orbitals there? There are 3 orbitals there. 3 p orbitals there. These 3 p orbitals are dumbbell shape, and already we studied about that. For s orbital, we studied about the node. What do you mean by node or nodal surface? The node means the region where their probability density is 0. Okay. The probability density, electron cloud, it is 0. That place is called a node. Okay. For s orbital, 1s orbital, there is no nodes. Okay. Because the electrons, it is very close to the 1s orbital, it is very close to the nucleus. So here, no node. Okay. All the place, it is the positive nucleus, it is attracted by the electrons. Okay, so here no nodes. For 2s orbital, there is one node. Okay, this is the nucleus, this is around the nucleus, and 2s orbital, here only one node. For 3s orbital, like that, 2 node. 3s orbital, 2 node. The ns orbital, n minus 1 node. Okay, but the p orbital, the 2 lobes are separated by only one node. Okay, only one nodal plane. This is the nodal plane. Okay, for p orbital, only one nodal plane are there having. For each p orbitals have only one nodal plane. Understood? And then the shape of the p orbital, the size of the p orbital, already we studied about that s orbital. The size of the s orbital, it will be increases when n value increases. Okay, n value increases, the shape size of the orbitals also increases. Okay, the p orbital like that. The size of the p orbital, for size of the 2p orbital, it is smaller than 3p orbital, it is smaller than 3d orbit, 4p orbital, it is smaller than 5p orbitals. Okay, these are about the shape of p orbitals. Okay. And then we are going to study about the shape of d orbital. Shape of d orbital. Here, what is the value of d? The value of d is equal to 2. L value is equal to 2. What about the m value? M value, here, how many orientations are having here? There are 5 orientation. Okay, you can write minus L2 plus L through 0. So L value 0 here, 2 here. So we can write minus 2, minus 1, 0, plus 1, plus 2. There are 5 values are having here. Okay, these 5 values indicates here 5 orientations are having. These 5 values are m values indicate here 5 orientations are having. What are the 5 orientations? The 5 orientations designated as dxy, dyz, dxz, dx square minus y square, and dz square. Okay, what about the 5 orientations? dxy, dyz, dxz, dx square minus y square, and dz square. Okay, how to draw the shape of d orbital? How to draw the shape of d orbital? first upon dxy orbital. dxy orbital. This is the x-axis. This is the y-axis. Okay. So here, for dxy orbital, these orbitals lie between the x and y axis. Okay. So dxy orbital, it lies in between dx and dy axis. Okay. And then what about the dyz orbital? dyz orbital, it lies in between y-axis and z-axis. This is the y-axis, z-axis. So dyz orbital, it lies in between dy and dz-axis. Understood? And then dxz. How to draw the dxz orbital? This is the x-axis and we can take it as the z-axis. Okay. So dxz orbital, it lies in between x-axis and z-axis. Okay. dxz axis. After that we can draw the dx square minus y square. How to draw the dx square minus y square orbital shape? The dx square minus y square, it lies along with x and y axis. This x axis, this y axis, the orbital, it lies in between, along with x axis, and along with y axis. Okay. And dz square, x and z square. Okay. The dz square orbital, it lies along with z axis. The electron cloud also having the center of the axis. Okay. So what is the shape of d orbital here? The first three d orbitals. What are the first three d orbitals? dxy, dxyz and dxz. These three d orbitals are in clover leaf shape. Okay, dxy, dyz and dxz orbitals are clover leaf shape. Okay. After that, dx square minus y square orbital, also the clover leaf shape, but it lies along with x and y axis. Okay. But first here 3 d orbitals are clover leaf shape. The lobes, how many lobes are having here? There are 4 lobes are having. These 4 lobes are lies in between the axis. Okay, in between the axis. But here this dx square minus y square, here the 4 lobes are lies along with x and y axis. Okay. But here the dz square orbital, what is the shape of dz square orbital? It is the dumbbell shape. But here the definite shape, electron cloud, it is having the center of the axis. Okay. The definite shape means halo ring shape. Okay. This shape, electron cloud, is having the middle center of the 2 lobes. Okay. Understood. So here the d orbital totally 2 lobes are having. For f orbital totally how much lobes are having? 4 lobes are having. 4 lobes. Okay. These are about the shape of the f orbitals. Okay. Here each lobes are separated by 2 nodes. So every f orbital having d orbital having 2 nodes. every p orbital having only one node. Here every d orbital having two nodes. Nodal plane. Understood? These are the shape of the d orbitals. Okay, understood? And what about the f orbital? What about the shape of f orbital? Here, for the f orbital, L is equal to 3. What is the L value here? L is equal to 3. Okay, M is equal to 5. M is equal to 5. How much values for M? It will be start from minus L to plus L through 0. Here L value 3. So we can write minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay, these are the 7 orientation of f orbital. Okay, these 7 orientations represents 7 orbitals. 7 orientation represents 7 orbitals. Okay, the 7 orbitals designated as f, x, y, z, f, x, z square, f, y, z square, f, z cube, f, z, x square minus y square, f, x square minus 3y square, f, y, 3x square minus y square. These are the 7 designation of f orbital. What are the 7 designation? F, x, y, z, f, x, z square, f, y, z square, f, z cube, f, z, x square minus y square, f, x square minus 3y square, f, y, 3x square minus y square. Okay. About the shape of the f orbital is more complex. Okay. But it follows the same rules based on p and d orbitals. P and d orbital having the lobes, okay, along the axis and between the axis or lobes are having. Here also having the same rule. When completely full, it is similar to the d orbital. Okay, it is completely full, it is similar to the d orbital, but it cut in half. Okay, 8 lobes instead of 4. For p orbital, for f orbital, for d orbital, how many lobes are having? There are 4 lobes. Okay, but here f orbital, totally 8 lobes are having. Totally 8 lobes. How will you draw here? First x, y and z axis. Okay, here this is the up center of axis. Up of the center axis has 4 lobes, and down of the center axis has 4 lobes. Okay, for f orbital totally how many lobes are having? 8 lobes are having. It's very difficult to draw. Okay, and how many node? The 8 lobes are separated by 3 nodal plane. For f orbital, how many nodal planes are having? Totally 3 nodal planes are having. Understood? These are about the shapes of p, d and f orbital. Okay, you know this orbital, this is the only one orientation, only one orbital is having. What is the shape? Spherical in shape. The p orbital total how many orientations are having? There are 3 orientation, px, py and pz. What is the shape? Dumbbell shape. What is the shape of d orbital? How many orientation? D orbital 5 orientation. D. What are the 5 orientations? dxy, dyz, dxz, d s square minus y square and dz square. Okay, the dxy and dyz and dxz, these 3 are the covering shape, and dx square minus y square, it is also covering shape, but the orbitals lie along with the axis, and dz square it is dumbbell shape. Okay, dumbbell shape, and middle having the electron cloud. These are the shape of and orientation of d orbital. And what is the orientation of f orbital? Totally how much orientations having the f orbital? Totally 7 orientation. What are the 7 orientations? 7 orbitals. Okay, what are the 7 orbitals are designated as f x y z f x z square, f y z square, f z cube, f z x square minus y square, f x square minus 3y square, f y 3x square minus y square. Okay, this also a clever leaf shape, but it is very difficult. It is complex shape, very difficult to draw. Okay, these are about the f orbital. So today assignment, draw the shapes and write the orientation. Draw the shape of P and D orbital and write the orientation of, write the designation or orientation of A and the P, D and F orbitals. Okay. The shape of the P, D orbital, you can draw like this. Okay. And you should write the orientation of F orbital. Okay, it is very important. This is the time to study. Okay. If you study well, you can write the electronic configuration for various elements. You can write clearly. Okay. Students, take page number 49. The shape of P orbital. For P orbital, L is equal to 1 and the corresponding M values are -1, 0 and +1. Okay, the angular distribution function are quite complex and are not discussed here. The shape of the P orbital as shown in figure 2.8. Okay, these 4 lines no need to study. First 3 lines and after that the 6th line onwards you have to mark. The 3 different M values indicates that there are 3 different orientations possible for P orbitals. These orbitals are designated as Px, Py and Pz, and the angular distribution for these orbitals shows that the loads are along the x, y and z axis respectively. Okay, and then you can mark that 2 P orbitals have one nodal plane. Up to here you mark. And then after that, the shape of D orbital. For D orbital, L is equal to 2 and the corresponding M values are -2, -1, 0, +1, +2. The shape of the D orbital looks like a clover leaf. The 5 M values give rise to 5 D orbitals, namely dxy, dyz, dxz, dx square minus y square and dz square. The 3D orbitals contain 2 nodal planes. Okay. After that, shape of F orbital. For F orbital, L is equal to 3 and the M values are -3, -2, -1, 0, +1, +2, +3. Corresponding to 7 F orbitals. F is at 3, F x z square, F y z square, F x y z, F z x square minus y square, F x square minus 3y square, F y 3x square minus y square. There are 3 nodal planes in the F orbitals. Okay, students, study well. More and more written practice take. Okay. Thank you all of you.